Good morning. The topic for today is time division multiple axis. In the previous section, we have seen about frequency division multiple axis, and we told that the 1G systems which use analog signals go for FDMA. So next is time division multiple axis. Mostly the 2G systems, namely the GSM, they go for they have digital signals, hence they go for time division multiple axis. In time division multiple axis, TDMA system divide the radio spectrum into two time slots. Each slot only one user is allowed to either transmit or receive. So we have a forward channel, we have a reverse channel separated by time. Time division multiple axis. So the beauty of time division multiple axis is the user gets to enjoy the entire bandwidth but at different time slots. So the entire bandwidth is available to the user at different time slots. So for example, a GSM user has 8 users, so there will be 8 time slots, and the ninth time slot will be allocated to user 1 again. But they get to enjoy the entire bandwidth, unlike the FDMA, where only a part of the bandwidth is allocated to each user. TDMA system transmit data in a buffer and burst method, thus the transmission for any user is non-continuous. This implies that unlike in FDMA system, which accommodates analog FM, digital data and digital modulation must be used with TDMA. So we have discussed in the first slide itself. Uh, so analog signals usually go for FDMA, and only digital signals and digital modulation must be used with TDMA. The transmission frame. The time division multiple axis transmission from various user is interlaced into a repeating frame structure. So this is one frame, it has a preamble, information message, it has a trail bit. We have slot 1, slot 2, slot 3 up to slot n depending on the number of users. So each slot, the frame has all these bits: trail bits, sync bit, information bit, guard bit. So other than the information data, all the other bits are called as overheads. So overheads are required for transmission from one node to another. Time division multiple axis, it can be seen that the frame consists of number of slots. Each frame is made up of a preamble, an information message, and a tail bit. In TDMA TDD, half of the time slot in the frame information message would be used for forward link channels and half would be used for reverse link channel. In TDMA frame, the preamble contains the address and synchronization information that both the base station and the subscriber use to identify each other. So the preamble always contains address and synchronization information. So address where the packet has to go. Guard bits are utilized to allow synchronization of receivers between different slots and frames. TDMA shares a single carrier frequency with several users where each user makes use of non-overlapping time slots. The number of time slots per frame depends on several factors such as modulation technique, available bandwidth, etc. TDMA uses different time slots for transmission and reception. Thus, duplexers are not required. In FDMA, duplexers are required, whereas in TDMA, duplexers are not required. Features of TDMA. Adaptive equalization is usually necessary in TDMA system since the transmission rates are generally very high as compared to FDMA channel. In TDMA, the guard time should be minimized. TDMA has an advantage in that it is possible to allocate different number of time slots per frame to different users. The efficiency of a TDMA system is a measure of the percentage of transmitted data that contains information as opposed to providing overhead for the access scheme. The frame efficiency is a percentage of bits per frame which contain transmitted data. So, efficiency in time division multiple access, the number of overhead bits per frame is BOH is NRBR plus NTBP plus NTBG plus NRBG, where NR is the number of reference bursts per frame, NT is the number of traffic bursts per frame, BR is the number of overhead bits per reference burst, BP is the number of overhead bits per preamble in each slot. BG is the number of equivalent bits in each guard time interval. So we come to this end of this section. In previous video, we have discussed about frequency division multiplexes. In this video, we have discussed about time division multiplexes. The next video, we shall discuss about CDMA, code division multiplexes. So FDMA usually goes with analog signal and TDMA goes with digital signal. Thank you.